function of leg and flexibility. Our runner here increased his stride angle 30 degrees and now covers 60% more ground with each stride, 31% more ground than Ryan with each stride he takes. Since he is taking fewer strides, he is also bouncing up and down less. We measure the overstride angle of the lower leg when the foot first touches the ground. For maximum efficiency, you want a large negative overstride angle, as you see here in Samuel Wanjiro. Stride angle is the fastest way to reduce the overstride angle. Many distance runners lift their toes as they run due to chronic tension. Toe lift is the main source of shin splints in runners. Meb has a toe lift angle of 35 degrees. Runners lift their toes by contracting their
If you align
muscles.
your posture, you use the strongest part of your body, your structure, your skeleton, and not your muscles to hold yourself up against this force. In alignment, your muscles can also relax, reducing resistance in your running motion. Your second job is to move forward. If you can cooperate with the force of gravity, it can propel you forward. A simple principle of physics says that if you take your posture line and lean it into gravity, there is an external force pulling you forward. This forward pull turns running into a controlled fall. What this means is that it's possible to run without using your legs for propulsion. The key is to maintain your posture line and lean efficiently from relaxed ankles. But as you move forward, there is a second very big force to cooperate with. This is the force of the approaching ground. When you are moving across the ground is actually coming at you. You have two choices. One is to let your feet land under you, where they can move with this force as it simply goes under you. The other choice is to let your feet land in front of your body, where they oppose this force. In this case, the force goes up through your body instead of simply going under you. To summarize, in this position, you are cooperating with gravity at the top and cooperating with the approaching ground at the bottom.
Baby, you got me out of reach. Oh. You got me out, you got me breaking out.
Stride angle is mainly a function.
Watch this athlete's head. This shows the cause of the visible effect of his head bobbing up and down. The overstride of the athlete entails his striking the ground first with his heel.
The
This
vertical
creates a
distance
full-
that makes it so tough. Bounce is how much a runner moves up and down with each stride. Ryan Hall, for instance, moves up 4 inches with each stride. 26,200 strides times 4 inches equals 8,725 vertical feet, or 1.65 vertical miles. This is equal to running up 6.4 former World Trade Centers in a little more than 2 hours. Ryan also drops down 4 inches with each stride, which equals another 6.4 World Trade Centers. This adds another 1.65 miles to his marathon for a total of 3.3 additional grueling miles just from bouncing up and down. Each time he drops down 4 inches, Ryan lands with more than twice his body weight. Multiply this 26,200 times, and he lands with a total of 6,812,000 pounds. This constant up and down motion or bounce is the main source of fatigue during the marathon.
You should focus your eye on the center of gravity of the athletes running toward you. If the center of gravity moves from side to side, there is a definite braking action as Newton's law is being violated. Here we have an athlete who has serious body balance problems. It is apparent that his feet are not landing under his center of gravity. As a line is drawn vertically from his center of gravity to the plane of the ground, you can see that the feet land to the side of this plane. This causes the resultant actions of 1, the arms flaring to the outside, 2, the head rocking back and forth from side to side, and 3, the athlete's hips moving from side to side, the main and only genuine fault. This violates Newton's law of motion and causes a break to the forward velocity, but equally important, a considerable amount of body energy, endurance and power must be used to stop the lateral movement. If the athlete could alleviate this body imbalance, his efficiency would improve, which means that he would move faster with an even lesser amount of energy expenditure.